Okay, so in this video I demonstrate basic router configuration. What I'd like you to do is you pause this video and then you bring up a new packet tracer file and then put in two routers. I use the 2911 routers. Place two routers, two 2960 switches and at least 4 PCs. Then maybe add in these few details, the IPv4 address, IPv6 global unicast addresses in. Just put this information on the side just to guide you along as you configure this by watching this video. Okay, so you will notice I've configured one side of the network just to make ease of recording this video, ease of configuration. We'll go through configuring a router R1, do the demonstration, and then you can use that to complete the rest of the network. Do the same configs on R2, and then we can see if we can connect both R1 and R2. So probably part 1 will be on configuring the router, and then we'll have another part 2 session where we will interconnect both R1 and R2 and then check if PCA can be able to ping PCJ or PCK, which is on another network. Okay, so we begin off by looking at part 1. So in this module, if you look at module 10, basic router configuration, the main objective is for you to be able to implement initial settings on a router and end devices. Pretty much straightforward. So we'll follow through by looking at part 1, part 2 and part 3. Part 2 and 3 will be done together. So we'll begin off by part 1. If you click on R1, in terms of the actual configurations, again we will need the end device. Okay, for example, we use a router. We connect a console cable from the laptop to the console port on the router, and then we'll go to use a terminal application like PuTTY, and then we access the global command line interface, the CLI. Okay, so first things first, when you log into a router, the default interface you go into is the user exec mode. Okay, so that's shown by the greater than symbol. Routers, okay, that's the basic config. So there's nothing configured yet, but let's just go enable, do a show version to see what's the version of the iOS configured inside here. Okay, so you check the version. If you do a show ver or show version, this is the information we are looking for. Okay, C2900 Universal K9 M version 15.1. So for most of the routers that we will be using, you'll either find version 12 or version 15 in packet tracer. You may see differences between the iOS versions in packet tracer and the actual iOS we'll find in the real hardware devices. So towards the end of the semester, when you come for your boot camp, in the boot camp we'll be using the actual hardware. So there'll be a few variations in the iOS within the actual hardware. Okay, so the iOS here is stored inside the flash. So we can see here system image file flash C2900 Universal K9 mz.spa15. That's the actual file name. Okay, that's the iOS file name. So if you were to use TFTP to update or do any changes or copy the iOS here, that's something I'll show you later. From an actual router, this is what you need to look for. So you need to copy paste this when you're doing the TFTP. So anyway, that's one of the basic things you need to check. Do a show version. You can do a show flash. Okay, so if you do a show flash, it shows you what's inside the compact flash of the router. Okay, so you will typically find the iOS. There might be more than one iOS stored inside, but normally which iOS to boot from, you use the system boot settings to specify what iOS your router will boot from. Okay, so here we're trying to do basic configuration, so I'll go straight ahead and type conf t. Okay, so remember, to make configurations we have to go into the global config mode. So when you're in the global config mode, then you can use commands that will adjust or make changes to the config settings. Okay, so from here, let me just go back, exit again, and I'll do a show run. Okay, so most show commands we can use them in the privileged exec mode. If I do a show run, it's very basic information in the running configs. That's been okay. So all interfaces, no IP address configured. Duplex is auto. Speed is also set to auto. Okay. LAN con 0, no passwords. VTY, no passwords. So no, just basic configuration in the running config. So let's go ahead and change the host name of the router, meaning this default router. Let's change that to R1. Okay, so I'll use host name R1, and that changes the host name of the router to R1. So that's the first thing we will change. Another command you might want to use is no IP domain lookup. Okay, no IP domain lookup. The purpose of this is we do not want anytime we type any commands by accident for the router to start searching if that command exists. So it does not need to do a domain lookup every time we mistype a command in here. So I use no IP domain lookup for that purpose. Okay, so no IP domain lookup. The next thing we would want to do is put a privileged exec password. So no enable secret. I'll just use Cisco, but Cisco is the password. The parameters are enable secret. So you can change it. You can change that. You can use your own password. So that sets the password for the privileged exec mode. So when we type enable, it should ask us for a password. So enable secret Cisco. Let's secure the console. So there's only one console. So you type LAN con 0. You set the password. I'll use class here. For most of our lab activities, we normally use Cisco and class as passwords. So they're easy to remember. And enable that by typing in login. Okay, so that's setting console password for R1, LAN con 0 password class login. Okay, another thing, let's enable virtual terminal interfaces 0 to 4. So we're opening only 5 terminal interfaces. That's 0, 1, 2, 3, 4. So LAN 0 to 4, enter, login, oops, password, okay, class, okay, login. So we can disable this later. This is by default for telnet connection. We can disable this later. I want to specify transport input as SSH. So instead of using telnet, I want to use SSH, which is much more secure. So I'll add that transport input SSH. What I'll do is I'll go back, because I'm setting this as SSH. One of the things you would like to do is, if you're managing the router from anywhere on the network, out of the box console, okay, from anywhere on the network, typically you would use either telnet or SSH. So far we've learned that telnet is not very secure, okay, because it's plain text. So we want to use a secure shell, which is SSH. Okay, so here I've already allowed for transport input SSH. So let me check IP space question mark. Can you see that we have SSH here? Okay, so SSH, leave a space question mark. Okay, so let's do version. Okay, so let's enable version 2. Okay, so it's asking to please create RSA keys of at least 768 bits size to enable SSH version 2. Okay, so 768 is the number we're going to use. So let's go crypto, leave a space, key, leave a space question mark, generate question mark. RSA, general keys, question mark, leave a space, modulus, leave a space. Okay, so size of the key 768. Okay, it's asking us to please define a domain first. Okay, so IP domain name, just use corona.com, pun intended. IP domain name corona.com. Okay, so crypto key generate RSA, general keys modulus 768 again. Okay, so now it tells us generating 768-bit RSA keys, and SSH enabled, SSH2 has been enabled. So let's confirm. That's one of the basic things, initial router settings. Okay, so we want to enable SSH. Okay, that's part of it. There's still a few more configs we need to do. Service password encryption is another one. Okay, so service password encryption basically encrypts all the passwords that you normally use on your router. For example, the enable, you could go enable class, but the word secret encrypts it. Okay, makes it, you are not able to see the password when you go into show run. But to ensure that all the passwords, plain text passwords, are encrypted, this is the command to use, service password encryption. Okay, so let's create a message that people will see when they log in. So this is known as a banner message of the day. Okay, so I'll use the add symbol, hit enter, and I like to do this. I put asterisk. Okay, unauthorized access is prohibited. Device is managed by ICT services. Okay, put another line of asterisk and hit enter, and use the add symbol again to close the banner message off. Okay, so that's the banner message of the day. We've enabled the SSH. We've set a password for console access. We've configured the privilege exec mode passwords, etc. Banner message already done. Okay, basically all initial router config settings, we've configured them. Okay, so we need to save this configuration. So if you exit and you do a copy run start, that's short for copy running config to startup config, that should save everything. So destination file name, we don't want to change it, leave it as startup config, just hit enter. Another method to do this is type write or WR. So you will notice most of the time I use WR just to write to memory, write the running config to memory. Okay, so that's part 1 complete, configuring initial router settings. Let's verify. Let's exit. Okay, you see it's asking for a password, and can you see the banner message appear? Okay, so password should be class, that's console. Okay, privilege exec mode password should be Cisco there. Okay, so I've confirmed that. Okay, basic settings are all configured. Okay, and now let's look at the interface. So before we configure the interface, I'll close this. We need to add a cable to R1. I'll use the G00 interface to the G01 on the switch 1. Switches, we won't configure them, they work out of the box. So for this demo, we'll just leave that as it is with the basic configs. Connect the PCs to the switch as well. Okay, so now we need to go ahead and configure this interface. Okay, so we are now on part 2. Okay, so let's go back to conft interface, so int G0/0, and notice we're going to use 2 IP addresses. We will configure IPv4 as well as IPv6. Now here you can see that this is a network address 1.0 subnet mask or prefix of /24, IPv6 global unicast address of again 1.0/64. So I'll be using both addresses. Okay, I'm configuring IPv4 and IPv6, and we'll enable unicast routing to enable IPv6 on our network. Okay, so here we type IP add or IP address. Okay, again notice IPv4, you just type IP add 192.168. So for that interface, this interface will serve as a default gateway to this network. So we'll type 1.1 255.255.255.0 IPv6 add. Okay, so we're now configuring the IPv6 global unicast address, db8 CAD 1, I'll use 1 and the prefix. Okay, so don't forget to do a no shut that turns the interface on, so you should be able to observe this LED turn from red to green. This one will go from amber to green. Okay, so that's it, and WR or copy run start to save the running config. Okay, so we've configured the interface as well as the default gateway. We've configured the default gateway on the router R1. So this default gateway will ensure that anytime PC A and B want to communicate with devices outside of their network, they need to know the default gateway address. Okay, the router will use that address to forward packets onto remote networks. Okay, so let's verify this. PCA, go to desktop, ipconfig 192.168.1. I'll give this one 10, and I'll put in the, for now I'll just leave out the default gateway first. Okay, I'll give this one 192.168.1.11. okay, let's leave out the default gateways for now. Okay, from PCB I'm going to ping PCA 192.168.1.10. notice reply is successful. Okay, so in this case it's local. Okay, local communication, so it does not need to go to the default gateway for it to support that. Even if it wasn't connected to the router, they will still be able to communicate. But okay, if PCB were to communicate with PCJ, we need to configure the default gateway on this end. Okay, so you need to add the default gateway here, 192.168.1.1. okay, that's the default gateway. So this will allow PC A and B to be able to communicate with remote networks that are also connected to R1. Okay, so that's configuring default interfaces. What I'd like you to do now is go to R2 and do the same. Okay, in the next video what I'll be doing is I'll be connecting R1 and R2, and then we're going to see how PCA and B can be able to communicate with PCJ and PCK. This is not part of the module of this lesson, but I thought it would be useful to help us into what we're looking at here. When you're configuring R2, please note that you use 192.168.2.1 for G00 interface. One more thing I forgot. When you're configuring interfaces, if you go to int G00, we can add more than one command. I'll just put question mark here. It's a good command. You should use question mark. Every time you're not sure what command to use, type in question mark. It will give you a list of commands that you can use in that mode. So I'm in the interface config mode here. So in that interface config mode, I can apply a description also to this interface. So that's one thing I'd like to use here. Description. Okay, so I'll call this default gateway. Oops, default gateway for LAN 1. Okay, we'll come across this later. It has its use when we are creating Ether channels. We use this channel group. If we are going to combine multiple physical links into logical channels, we can use that. Okay, we've used crypto already. You can change the bandwidth. All these you don't need at this stage. We've used these two. Okay, if you wanted to negate a command, let's say you want to remove the IPv6 address, you can use no IPv6 192.168.1.1 etc. 255.255. That means you are removing now that IP address. Okay, so let me just end this. do a WR to write to memory. I'll do a show run again, and you can see now, you see service password encryption. We've set all of these basic things here. Okay, SSH is enabled. Okay, domain name corona.com, and we have the interfaces up. IP address is also assigned. Okay, so let's test something. Remember that we configured SSH. Okay, so let's verify if we can access the router without adding a console cable from PCA to the router. So because PCA is connected to the network, we go to PCA, use terminal, and oops, not terminal, we use command prompt. Okay, so SSH, remember with telnet, you'll go telnet 192.168.1.1. Okay, notice it's trying to connect but closed by foreign host because we set transport input SSH. So it will only allow for SSH. So SSH -L, that's not -1, that's -L. That's login. Username is admin. Password is 192. Host. The device we're trying to connect to is 1.1. Okay, so it's asking me for a password, and again, password is admin. Okay. Okay, so notice it didn't allow me. Okay, so if I go back to R1, I think I forgot to put something here. Username admin, password, let's say SSH pass. Okay, so end WR. Okay, so I'll go back to PCA, command prompt, SSH -L, username is admin, 92.168.1.1, SSH pass, oops, SSH pass, oh, it's pass. Okay, so something is wrong there. Okay, so let's go back to the router, conf t. Let me go to LAN VTY 04. Okay, so I've done transport input SSH. Let's set to login local. Okay, and save that. Let's go back to PCA. Hopefully this time it should work. SSH -L admin 192.168.1.1. Oops. SSH -L admin 2.168.1.1. Password SSH pass. Alright. Okay, so login local was the command that was missing. So login local, we are asking, we're basically telling the router to check for the username and password within its own configurations. So when we added login local, so we are now able to enter. Okay, so you can see from PCA, I'm able to access router 1. Okay, so I can type enable, and I'm into the router. Okay, so in this way, we no longer need the console cable. You can manage the switch from anywhere on the network, as long as securely, as long as the PC you are trying to access the router is connected to the network. Okay, so I'll stop here. Use this to try and configure this side of the network, and in part 2 we're going to connect both R1 and R2. We won't use a Ethernet cable. Okay, we'll use a serial cable, and then we'll simulate what happens in a logical or physical point-to-point link, okay, between R1 and R2. Okay.